All right, so I'm going to walk through my code for the uh, porting project. I chose to do the pathing one, and I actually used LibGdx, which is the framework that I'm planning on doing my capstone project on for the pathing project. There's a lot of things that I uh, learned while I was doing this. For one, I was not real successful on the pathing for doing Android Studio. LibGdx is really just kind of like a frameworks library, but it allows me to have access to the OpenGL 2.0 and um, makes it a lot easier to have things rendered to screen and have that whole process instead of having to set up the Surface Views using Android Studio. So here's just an example of it. So this is the main one. The black blocks are the walls, and so when it draws, that's my start block. That was my end block. Here's my path that it draws. Well, my reverse path after I figure it out, and I'll walk through that. And then all of the lighter green or the forest green are all of the visited paths, or excuse me, all the visited cells. And then when I click on again, it resets. The end becomes a start, and then I can click to generate another path. So I have it where it's easily resetting. What I did end up having to set up, because there would be times where a path is impossible. Like here, I cannot put an end cell there without it airing out. It will fill up all the squares and will not be able to go here. So I have it where when it reaches kind of like the end of file error, where it will reset if it realizes that there's not a path, so that I can just reset the whole pathing thing because it's an impossibility instead of it locking up the system. So there's where it resets. It reset again. I did have to do quite a bit of bug testing to track down my algorithm as I was doing it. Here, because it kept it was not doing the most efficient path. It was kind of doing almost more like a depth first search, and it was not including the 6 columns on the right hand side. So this is me actually going through. Let me get all the way to the top. Tracking down the code using a lot of log functions. So first thing that I did was notice that it was not, all the centroids were actually the same because it was doing it in the middle based on the cell and not based on the distance. And then checking that it's actually running and it's pulling the current position from the first one, checking against the cost, seeing if it has been visited or not and what the current cost is. So I have it doing half of the max value so that I can actually add the H cost and the M cost and not have it go all the way back around to negative numbers for if I'm adding them together, but still be much larger than anything that I need. So that was another issue that I was tracking down. So then it's doing the H cost, the Manhattan distance for each point as I'm working my way down, and then letting me know like where it is in the code, which one it's calculated, and then telling me where it is in the queue. And then once it's checked all of the neighbors, I can see that it's taken the 5, 4.9, 4.9, 4.9. I can see that it's taken 5 3, that cell, that's what becomes my new current cell, and then it removes it, and I increment up and continue on working through the entire process until I generate a path. So my code for LibGdx, when you initially start, you have one class which is just doing application adapter, and then I implemented the input processor so I could, instead of building a whole bunch of classes, I really only did 2 on this one. I basically have just a nav cell, and then the one that is setting up and drawing and doing all the computations and everything. So this is my main class. So I have my nav cells, my mstart, my mcell end, my priority queues, and my different array lists. One for the path that it generates from back to front, and then I reverse it. So it first jumps into the create it jumps here first when it first opens up, so that's where I can do my sprite batch, which I'm not actually using. I'm using most of shape rendering just for the shapes for all the squares and everything, and then setting my camera to ortho into that width and height, and then setting my input processor. These are my touch points for when I'm clicking on the screen, that I can have it store the endpoint. And then I call load new map, which I have all the way up here, which now I'm calculating the different columns and rows based off the screen size. And then from that screen size, I am building an array of M cells and filling them all in, setting the bounds, and then setting the centroids for all of those using vectors instead of points. So that was my first issue, is that when I didn't have where I was doing I and J for each of the rows and columns, it just kept making them actually all the same. So my Manhattan distance was always 0. That's why it wasn't drawing correctly. And then I call to create walls. I make sure that everything's clear. So my mcell start is calling that mcell start function. My mcell end is going to be null until it gets touched. And then I'm making sure that my priority queue is empty. So then I go to the set the walls, which is this first function right here, which I'm just going, that first screen that you've seen that was doing the mid row, making those impassable. And then I go to mcell start, which is spitting back a randomized position, as long as, and it's randomly doing it, but it's making sure that it's not doing it on a impassable, like a wall. It's not trying to put a point there. And then after I get to that point, then it's basically just kind of frozen until I have a touchdown event where, if there is no cell end and it's empty, then it's going to call. I'm basically taking that touch point, which is a vector 3, and on projecting it from the camera, so I have accurate coordinates for the screen and not where it was touched. And then I'm using that to build my mcell end, and then I'm setting my neighbors. So the neighbors is right here. This is where I'm iterating through. This was where I had another of the issues. So I'm iterating through every single cell in the M cells and checking if it's passable. Then I'm setting the neighbor to it, working from north, east, southwest, and checking each one that I can actually create a neighbor, and then I set that as the neighbor for that individual cell. After I do that, then my rendering calls start going in, which is here. So that's where it's actually drawing the screen with that kind of gray color. I'm updating my camera. I'm setting my shape renderer batch to uh, the projection matrix, and then I'm filling in the all the impassable areas as like solid black. And then I have, because it works, from bottom to top on the Z order. So then I do the visited. If I have visited, then it's going to be drawing them as another. Doing the shape rendering, the batches are intensive, so you don't want to actually create more than one. And based on the documentation for using LibGdx, it's actually much better on processing power to do it kind of in bits. So if I need to do something, I draw it and then I end it and then I start it again and I do something else. So that's broken up based on task kind of thing. So my visited are drawn, and then I'm drawing my start square, I'm drawing my end square, and then I am drawing the path, and that's only if I have my reverse path done. So here is actually where I am doing it. So if I do not have a reverse path and my M cell end has already been assigned, I'm double checking that the cost has all been reset to everything that I want in my nav cell, and then I'm updating my first cell, I'm adding it to my queue, and then I'm going into my path builder, and then once it goes back around to the rendering, once it's not empty, it's going to start actually iterating through my reverse path, going and drawing it. But what I wanted to do is each time that it goes through the render, I want it to only do one square at a time so you can see it actually getting drawn out. So that's what this is right here. And then I am drawing the white line separating all the squares so that they're easily seen. And then once that finishes, and everything's done, then that's when my dispose would be called. My path builder is actually right here, where it's calling the pather, and then it's calling my reverse path. So once I go through my pather, so basically I'm just making sure that if the path is empty and the queue is not empty, so it just has that current in there, then here is like my base case. So once it ends up reaching the M cell end, I'm adding the current nav cell to the path and then checking all the previous ones, doing a while loop, and then reassigning the current as the previous to continue adding the path until I get to the end, and then it's kicking out. If it doesn't do that, then it's going through and it's basically checking the cost. So I'm taking my temp cost plus the M cost, which is just the movement cost. It's not the heuristic cost. That's based. That's how I do the ordering for the priority queue. So as long as the neighbor is not null and the neighbor is possible, then it's going to go into two statements. So if it's visited, then they're comparing the temporary cost, the current temporary cost, to the neighbor's current cost. And if it's less, then it's updating it, removing it from the queue, and re-adding it back in the queue so that it can recheck the priority queue. If it hasn't been visited, then it's updating the neighbor cell with the H cost and the current temp cost, and then adding it to the queue for the first time, and then setting it as visited. If it has not been, if the neighbor is not passable, it's just skipping. If it ends up making it all the way down here without actually having where the queue got empty, so this is actually where it would do it twice. If it gets to that point and I still don't have a reverse path, then that means I'm in kind of like a deadlock. It's impossible for me to actually get there, and then I'm resetting my pathing. So that's where I reset the costs. I reset everything to be passable. I clear my path. I clear my reverse path. I clear my queue. I create new walls, and that's where I build all the randomization for it to have kind of a huge general setup. Change my M start to whatever the cell end was. Change my M cell end to null, and then number for decrementing for how I'm drawing the path back to 0, and then that will open me back up to being able to use the touchdown point again, and continue on that way to click on the next thing. My reverse path, all it is really I'm just decrementing down from the path, and each one I'm assigning into that reverse path array list. So it's, back to forward is getting assigned in that order so that it makes it forward to back. So once it does end up finishing, if I do end up having a path, then it draws it, and then it's going to take me into here for my touch events. It's going to reset everything, change the start cell to where the end cell is, and then I can reset my neighbors and everything for the touchdown points. So that's basically my pathing project using LibGdx. Here's my nav cell. Not much is different from this, other than I made a couple subtle changes. Changed the pointers to vectors. The max value I actually have as divided by 2 instead of the full max value, which was an issue that I think I had in my last code when I did it the first time, so that when I'm doing my mcost final, it's not cycling back through and going into negative max values. My comparator is only being figured off of the H cost. When it was doing off the final, it was actually kind of doing more of like that depth first search, was checking a whole lot more cells as being visited before it would actually find a route. So I think it's much more efficient now. Again, I couldn't really use points, so I had to use vector 2s for the heuristic. This is a Manhattan distance heuristic. And then, yeah, that's basically it. This project, the process, actually I thought it was going to be a lot quicker, that I could just kind of copy code, and that wasn't the case. I actually had to kind of go use the reasoning that I had on the previous stuff, and then double check it and kind of check how I was going to actually implement it with this new framework to make sure that everything would work. And I worked the opposite way that I did the first time around. This time around, I worked focusing on getting the screen to draw first, making sure that I had all the squares filled out, that the nav cells were working, that it was generating the correct columns and rows, that it was visible, that it had the correct pixel count for what I was going to do for my cell size. And then once I got to that, then I was making sure that I could draw the start cell, the end cell, and then I started really just kind of following it through the logcat functions, the process of the algorithms as it was drawing stuff to make sure, and just kind of streamlining everything, fixing pieces when I was seeing that stuff wasn't working. So it was a really good experience. I'm a lot more happy with the pathing project now than I was before. It wasn't crashing the system, but it wasn't really drawing how I wanted it to. Most of the time it would end up resulting in a black screen, and I couldn't track down why stuff was going the way it was. So this time around, I felt like it was much more advantageous for me to do this, and I'm going to be using the A-star pathing, a lot of this code, for my capstone for having the enemy movements when I'm doing like my state machines, because I'm doing like a Zelda clone. So I can have the enemies actually, if they're in a certain state, then I can have them move to another location, and I can use the A-star pathing to just have them move there instead of having to, manually generate how they need to do it. Um, so that's basically my project for porting. All right, thanks.